May I know, please? Okay, now. So in this first question we're going to do today, so it says that basically when calculate the current through the ammeter when the switch S is closed. Now remember, if the switch here is closed like that, then the current which is traveling from the positive one, it will go through the ammeter, it will go here, it will cross 20, but it would not go towards 60, it will go from this path back to this. It will completely ignore that because it needs to go through the free path and not the resistors one. So then we can simply use V is equal to IR. We can say, okay, voltage is 6, the current we need to find, and the total resistance in the red path that I've just drawn is 20. So this will be 6 over 20. That basically comes out to be something like 0.3 ampere. Is it clear, everyone? Okay, now then it says when it is closed. Oh, sorry, my bad. When it was closed, this should be the answer. Sorry. Which means and I should be 0.3. This is not the same. So when it is open, exactly how they have shown it, so then the current has to go through this one, and then it needs to go through this one and then come back, which means that the total resistance will be, because in series you just add it up, so it's going to be 80 ohms, and then V is equal to IR. The voltage total is 6, you need to find the total current over 80, so this will be 6 over 80. So that would mean that this is going to be 6 divided by 80 is 0.075. Like that. Is it clear, everyone? Any questions that you have? Let me know, please. Okay, so then the switch is now replaced with the voltmeter or infinite resistor. Calculate the reading on the voltmeter. Now it says if we put a voltmeter across this, so what will happen? Now the current path is basically the same as this. We know the current is going through this as 0.75 ampere. We only want voltage across this one. Okay, so we'll use V is equal to IR. Current would be the same, but the resistance is 60, so we're going to multiply 60, and then it is going to be something like 4.5 volts. If you have any questions, let me know. Okay, now let's move to this one. Now in a circuit figure 1, the battery of EMF 15 volts and the negligible internal resistance, okay, just let it go. It says that two lamps and resistor are in series. We know that because it's connected by just one single wire. And now it says what is the voltage across each lamp. So now it's pretty simple. One of the ways to do this is that I'll tell you a long way and then I'll tell you the long way and the short way. The long way is that we can find the total resistance, and if we do that, we have to add all the resistances because it is like all of them are like 12, and they're they're basically in series, and then you can use V is equal to IR to find the voltage, basically current. So the total voltage was 15. I want to find the total current that's going here, and that's going to be 36. So current will be 15 divided by 36. So using my calculator, it would be 15 divided by 36 is going to be 0.42 amperes, right? Now, then we can basically, if I want to find voltage across each one, so current is the same, I can use V is equal to IR, and the current will be 0.42, which is same for each, multiplied by the resistance of the lamp. So that's going to be about 5.04 volts. So I can do that, almost 5 volts. Okay. The other way around to this is, which is very important, like, because it's just one mark, why would we do so much? Because if there are 3 lamps of equal resistance, then this would equally be divided. So what I can do is, if there are 3 lamps of equal resistance, I can do 15 divided by 3. So this will also give me 5. That could also be the answer. But that's a quick way. That's the real way. All right. Chavez, do you understand this? Caroline?
Yes.
Okay. Then calculate the current through the lamp. We've already done it basically through this. So that's 0.42 amperes. And then it says 2 lamps are now disconnected and connected in parallel, as you can see. Show that the current supplied by the battery is this. Now this is very important. You see, now this is a combination circuit. Combination circuit means that this side is basically parallel, and this side is basically, these two are in series with this. You already know that. Okay. So first of all, we're going to solve the parallel ones. To solve the parallel ones, we could do 1 upon R equals to 1 upon 12 plus 1 upon 12. So it is 1 upon R equals to 2 upon 12, and R will be equals to 6. Now these both have 6 ohms, and now because it is series with 12, so the total resistance will be equal to 6 plus 12, because in series resistance just adds up 18 ohm. Now you use V is equal to IR, the total voltage is 15, we want to find the current, and this is 18, so the current will be 15 divided by 18, and let's see if we can show that this is the answer. Wait a second, please. This will be 15 divided by 18, and this is actually 0.83 amperes, which is shown. Let me know if you have any questions here. Right. Nadia? Nadia? You here? Okay.
Sir, why did we do R is equal to 6 plus 12?
Why did we do 6 plus 12? Because this part of the circuit is in series with this part. So the parallel part had this total resistance. When you add up in series, we just add the resistances. Okay.
Okay.
Nadia, as far as I know, as far as I've been told, that you're in A2, and this is IGCSE class. I don't know. Are you sure you're in the right class? Okay. Alright. Let me see who added you. Second. Okay, never mind. So, okay, Yusra. So then we go to the next one, and okay, you don't have to do this, but we'll go here. Now in this section it says figure shows two resistors R1 and R2 connected in series with the battery of EMF 12 volts, as you can see, and says the reading on the voltmeter is 8. So here we have reading of 8 and the resistance of R2 as 60 ohms. Calculate the current. Now this is interesting, right? This is a bit, tough job here to do. The thing is that these are two resistors in series, okay? Which means if this one gets 8 volts out of total 12, can somebody tell me how much will this get?
4.
4, right? If this gets 4 volts, so the current in both of them would be the same. I can use this section of the circuit to find the current. I can simply say V is equal to IR. I have 4 volts. I need to find the current across the resistance of 60. So the current will be equal to 4 divided by 60. And then I can just use the calculator. So it's going to be 0.067. Do you guys understand this small trick here? Let me know if anybody has a confusion here. Hussein and Rabia, Zarish, Soha, Afan, everything's clear?
Yes, sir,
Okay,
I understand.
Now, then says calculate the resistance R. Since now we know the current in this is like in series, the current stays the same. We have the voltage across this, we have the current, so we can use V is equal to IR again. Voltage is 8 across that, the current is 0.067, and we need to find that R. So what you're going to do is you're going to simply 8 divided by 0.067, and that's going to be about 120 ohms, like that. All right, we get an answer like 119 because I rounded it off. If I had taken it 0.6667, it would give me the same. So around two significant figures. Now calculate the charge passing through the battery in this given appropriate unit. So now I know current is given by charge per unit time, right? I want to find the charge. I have the current as 0.067, and 2 minutes I need to change this into 2 times 6 into seconds, right? So I need to change that, and then I can find the charge. Okay, wait. So that would be, oh, okay, I need to pull this up, and it says no, I don't want to come here. Yes, please. Okay, please come here. Okay, this is weird. Never mind. 0.067 times 2 times 60. So it's basically 8.04, and the units will be coulombs. You can simply write C as well. That's fine, as long as you don't have to do this. And then come to question number 4. Now, in this question it says X and Y are two lamps. X is rated 12 volts 36 watts, so this is the voltage, this is the power of the lamp, and Y is rated 4.5 volts and 2 watt. Calculate the current in each lamp when it operated correct working voltage. So power is equal to voltage times current, we know this. For the first lamp, which is X, the power is 36, voltage is 12, and current is I. So 36 divided by 12, I think it should be 3, but let's just do it anyway. So that's 3 amperes. And for the other one, Y, I have to use power equals to VI again. Power of that is 2, voltage is 4.5, and current is this. So I'm going to use that. 2 divided by 4.5, and that's going to be 0.44 amperes. Okay. Okay, now the question now in the next one says two lamps. These two lamps are connected in circuit shown in figure below. And now this seems like a very complicated circuit, but trust me, it's not. One of the ways to solve this kind of circuit is it says calculate the potential difference across R1. You want to find this, right? Now the interesting thing is that we already know that from X at current working voltage we have 3 amperes of current going, and through Y the current is going as 0.44 amperes, right? Now here's a trick that you can play with the examiner. So you need to understand that the voltage that X was taking was basically about 12 volts, right? So it has 12 volts. This means that actually when this circuit, which is in parallel, you should understand that in parallel, if the whole branch, like if I color this whole branch in red is getting 12 volts, it means the voltage remains the same, then this branch in green would also get total voltage of 12 volts, which means the parallel section is getting 12 volts. So if out of 24 volts, which is the total, if the parallel section is getting 12, what will this be getting? Can you guess? 12.
12.
Yes, so that would be the answer. It's so simple. Just that trick where he's playing this mind game. So you should remember that from this point to this point, the voltage total, like in here, it is given as 12, which means then the voltage across this whole thing is also 12, right? So in parallel, voltage remains the same. So if this whole thing, this part is getting 12, the rest of the voltage will be here, which is 12 because of the 24 here. Do you understand? Like that. So you need to
Yes,
be
sir.
aware of that. Just be careful with that. And then it says calculate the current. Now it's pretty simple in R1 because we can use V is equal to IR. We have the voltage across it. I don't know. Oh, yeah, sorry. We don't have the resistance. Now look at this. So imagine this now, that the current that came out from here, I, went through R1, and then when it reached here, it needed to decide because it's a parallel circuit. Some of it went here and some of it went here. How much did this part, X part, did get? It was 3 ampere, and that one got 0.44 ampere, which means what would be the total current then? In parallel, the current can be added up. 3 plus 0.
3.44.
Yes, exactly, 3.44. Because now you can see from here it splits. So we can add both of them to find what is the total current that's going. See, so this is just a trick he's playing again. But we should remember the rules that I wrote in the notes, okay? Then it says calculate the resistance. Now it's pretty simple. The voltage is 12. The current is 3.44. We need to find the resistance. So simply pull up the calculator. 12 divided by 3.44, and that's going to be 3.5 ohms. Any questions? Anaya, that's very late today. What happened?
Sir, it wasn't allowing me to connect this time.
Sorry?
I couldn't connect. I
Oh,
couldn't connect, sir.
okay, okay, okay. All right. If something like that happens, message me. You can also look at the group. Okay. Anyway, now it says calculate the potential difference across R. Now we want to find the potential difference across R2. So imagine, now we know this. Now please look at this. If this whole part had 12 voltage, which means that this whole part is also has 12 voltage. Now the bulb is working at correct voltage, and we know y was working as 4.5 volts. If y is getting 4.5 volts out of the total 12, what will R2 get? What do you guys say? Should be like 12 minus 4.5, that is 7.5 volts. Okay, so that would be 7.5 volts. 12 minus 4.5, like that. And then it says calculate the resistance R2. We have the current, we have the voltage, so we can simply do that by using V is equal to IR. Voltage 7.5, current is 0.44 times R, so that's gonna be something like 7.5 divided by 0.44, and that's 17 ohms. Do you understand?
Yes, sir.
Interesting, interesting. Okay. Then, or you don't need to do this. You can come here. Question number 5, right? Okay, there are many questions, but this is what I'll do. Let's see. Now this circuit is again seems like complex one. This is not complex at all. It says that there are 4 resistors and EMF of battery is 10 volts, right? And the reading on the ammeter is 2.0 ampere. It says calculate the total resistance. So we have the total voltage, we have the total current. We can simply use V is equal to IR to find the total resistance. So the total resistance has to be 5 ohms, and I'm going to write it simply right here. So it's not that hard. 5.0 ohms. And then it says the resistor XY all have the same resistance. Show that your answer to part A consistent with the resistance in each. So we need to show that each one has 3 ohms. Now that's something to look at. First of all, let's say all of them have resistance R. Okay? So first, this part, if you look at this part is in series. Do you guys understand this? Then this whole part, which has the series one, is the parallel one. So first I'm going to solve this one, and then I'm going to solve this one, and then this combined with this part is series again. So I'm going to solve this on the third step. So I know I basically segregated each step, made the flow, that how I will carry it out. So for the first one, in series, I know that the resistance is R plus R. It is added, so it's 2R, which means this one has 2R resistance. Everybody understands? Good. Now, next is I'm going to solve these two as parallel. Now, in parallel, the total resistance is taken out by 1 upon R for this one plus 1 upon 2R for this one, because X and Y now we have clamped it together. So what you can do is you can take the LCM. like that, and it will be 2 plus 1. So 1 upon r will be 3 over 2r, or r will be equal to 2 by 3r. Okay. In case that you do not know how to take LCM of variables, what you can do is, this is like 1 upon r, this is like half r, right? So it's pretty simple. What you can do is you can use the calculator to it. Okay. Now, how do you use the calculator to it? It's pretty simple. You pull out your calculator, say, okay, I am going to write 1 plus 1.5, right? So that's basically 3 by 2. Automatically, it will give you 3 by 2r, as you can see. And then when you take the reciprocal, it will be like this. Do you understand? So you can simply use
Yes,
the
sir.
calculator as well, it's fine. Then, now it means these two have 2 by 3r. This whole section is 2 by 3. In the third step, I'm following this big series, which is this one and this one. So what I'm going to do is r 2 by 3 r plus r is equal to, now I'm going to pull up my calculator and see, 2 by 3 plus 1 is basically 5 by 3, which is 1 by 1.6 r. Okay. Now the total resistance, all of this is equal to 1.6 r, whereas I knew that the total resistance is equal to 5, right? So let's try this. So total resistance is 5 and it is equal to 1.6 r from this. So r will be 5.0 divided by 1.6. Let's see if we get the answer like that. So 5.0 divided by 1.6 is exactly 3.1 ohms. Is it clear? So it's consistent like that.
Yes, sir.
Yeah. So just teaching you how to be, how to connect, how to basically segregate each part of the circuit and one by one solve it, and you will never get anything wrong, because then you will have the ability, right? And then it says calculate the current in Y, and that's not too hard. Okay. Okay. Anyway, so now what I'm going to do is, that's pretty simple. In ahead of this, all of these are the same. Now I'm going to show you, I'm going to give you some of the questions from the past papers, so that you guys can basically practice a bit on your own as well. So let me see, where are my topicals? Um, 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 um. Got to be here somewhere. Okay. Okay. So these are the questions. I don't know whether these are the current or resistance ones. So this is resistance ones. I don't want to do that. I wanna, okay, this question. Now what I want you people to, okay, this is a different question. You won't be able to, not too good. Let's do DC circuits one. Okay. All right. So this question. Now everyone, I would ask you this in a bit. All I want you to do is, I want you to solve this. We have already done more difficult questions than this. It says the EMF of battery 6, the resistance of variable resistor is 1.8. So they've given this. It says determine the total resistance, and then current measured by ammeter, which is the total current. And then it says add a symbol for component measuring potential difference across 2.8 resistance. So we have to put a symbol here, and then that's what you want to do right now. So can you please try and solve this? You have 4 minutes. When the meeting ends, you got to rejoin, and then you give me the answer, please. Try and do part A and part B. Okay, so now I just want to see how many people have gotten right. So for this question, I'll just solve this up and see. Let everybody join back. Okay, so so here, like here, for the first one says determine the total resistance of the circuit, right? So if this is 1.8, again I'm just going to look at it this way, that from here till here this is a parallel circuit, and then I have to solve the parallel one first, and then I got to solve the series one, which is the outer circuit, right? So for parallel, I'm going to do 1 upon 3.6 plus 1 upon 1.8 equals to 1 upon r. You can simply use your calculator to solve most of these. So it's going to be 1 upon 3.6 plus 1 upon 1.8. And then you got to take the reciprocal as well. So r will be equal to 1.2. Let me double check. Yes, okay. Then because this hole is 1.2 ohms and then it combines with this, so the resistance will be 2.8 plus 1.2, so that's going to be 3 and 4.0 ohms. Writing the units are very important. How many people could do this? Please let me know. Ali, did you get it right? Anaya?
No,
Okay,
sir.
very good. Do you understand now?
No,
Yes.
Okay. Caroline, Chavez, Soha, Zarish? No? Okay. Now, then says the current measured by the ammeter. So you want to find this current. This is basically the total current. So we have the total resistance, we have the total voltage. We simply use V is equal to IR. The total voltage is 6. The total resistance is 4. So the current will be
1.1.
yeah 1.5, right? Amperes. You writing the correct unit is important. Then state what is meant by potential difference. So you should know potential difference is work done per unit charge by charges across a component in dissipating electrical energy to other forms. Now, then it says add the symbol of the component that is measuring potential difference across 2.8. So the symbol is a voltmeter and it should be like connected in parallel like that. Do you guys understand this?
yes, sir.
Sir, will the resistance be always less than the voltage?
Resistance will be less than the voltage? No, no, that's not true.
Okay.
Okay. All right. So I hope you guys have understood this. So I'm gonna put this